Okay, welcome class. This is definitely the first thing I said today because now we're recording. I don't know how this lecture is going to go, to be honest with you. I was instructed to just design functions with you, but like all I have at the moment are functions and booleans and arithmetic. So there's not many interesting things that I can do. So I have, I think maybe 10 questions that I want to do today, and I'm just going to code it sitting here and sort of talk so you can see my thought process when coding. You can code along on your laptops if you choose. Okay, so here's the first question. So we're really going to walk through the whole design process. So if each adult eats 3 cookies, each child eats 2 cookies, and each teen eats 5, write a function that takes 3 parameters representing the numbers of adults, children, and teens and returns the required number of cookies. Okay, so what did I write here? Okay, that's the answer. So I'm going to, from scratch, start to program this. Right? So I'm going to go over here. I'm going to open up my terminal. I'll make that a bit bigger. You can all see that? Yeah. I'm going to open up my IDE over here. Whoop. And I think that was on my desktop. Temp, perfect. Okay, so I have a file here, and I have that file sitting here. So if I type print 2 plus 2, and I then say Python 3 on temp, should print 4. Perfect, right? So you should always, once you save your file, just dump in print 2 plus 2 and see that it's actually working. So what did we want to design? A function that takes 3 parameters and returns the required numbers of cookies. Okay, so I guess a good name for that would be required cookies. And what do I want to take in? I want to take in adults, children, and teens. Adults, children, I'll make this bigger. Teens. And I want to return the required number of cookies. That's an integer. So I guess I'm taking an integer number of adults, an integer number of okay, so I'm not going to do that because it's really screwing up the highlighting. But I'll put it in the docstring instead, right? So what we can do instead, the old method is just to put in your docstring something like this, right? The required cookies is a function which takes an integer, an integer, and an integer, and returns an integer. So what else do we need to do? So so I got to write some type of description of this. So a function which returns the number of cookies consumed by adults, many adults, children, many children, and teens, many teens. Okay, so what do we have to return here? So each adult eats 3 cookies, so that's 3 times adults plus 2 cookies for each child, and a teen that eats 3 cookies. Okay, so we also have to put in some examples in the docstring. So maybe, required cookies. Required cookies for 1 adult, 1 child, and 1 teen should be what? 3, 5, I think I did this wrong. 3, teens eat 5, okay. So this is 5 plus 3 is 8, so this should return 10. Maybe required cookies for 201, or maybe 202 would be what? So that's 10, 0, 6, so that should be 16. Okay, so there's our function. So I'll show you a couple ways that we can do this. So if I just call Python on this file, nothing's going to happen. I can go down here, and I can say the answer is required cookies for 111, and then print the answer. Okay. And then I do this, and it fails, because this should be teens. 10. Okay, so that was right. Let's try 202. 16. Perfect. Okay, I'll show you another way that you can do this. So I'm going to remove all of this. If you have a file which only has, I'm going to define another thing here, G. If you have a file which only has definitions of functions in it, you can say something like this. I can say, okay, so I want to still work. So when I do this, and I'm here, right, this is called the interactive mode. Right? So because you can interact with the Python shell and say a equals 1 and a equals a plus 1. So I can say something like Python 3, enter interactive mode, but read in this file. Right? So I do that, and as you see, now I have access to required cookies. Right? I also have access to G. Right? So that's a good way of like writing long definitions and reading them into the interactive mode, right? Instead of like doing this and pasting, right? Because for one, you can go back into here and make quick changes and reload the sheet. So let me get out of here. There's other things I would like to show you. Did I do it on a slide? Okay, well, I'll show you here. Okay, so when we enter Python in this interactive mode, so I'll do this. I'll also do this. I'll say, yeah, a is equal to 7. So I'm going to read in that file to my interactive Python sheet. So something that would be useful to know when you're in Python is to ask for a list of things that are defined, right? Because currently I have access to A, I have access to G, right? But I only know that because I can look at the file. So you can type in dir, which will give you a list of everything that is currently loaded by Python. So you could ignore all of these, right? Those are special environmental variables, and maybe you'll learn about them one day, but they're certainly not useful at the moment. So ignore those, but you can look. Maybe we'll just look at the last 3. Oh, I did that the wrong way. -3 to end. Yes, okay. So those last 3 in dir are saying, okay, so you've loaded A, right? So you have some name available called A, you have some name available called G, and you have some name available called required cookies. Although you can always ask for the type, right? So the reason that we're writing these doc strings is for this reason. So suppose you run dir and you find that you have some function called required cookies. And you have no idea how it works, right? Because perhaps your friend gave you the file, and he didn't give you any other information. So you can always type help, and then type in the name of the file, or the name of the function, right? And it's going to print this to the screen, right? So what it's printing is the doc string. Right? So this is why we're encouraging you to write doc strings, right? So when you load it into Python, if I'm using it, I can quickly hit help and see a little bit of information. It's like, this is enough information to start using the function, right? I can tell what it's expecting, I can tell what it's going to return. It has the sort of very high level description, and it has a couple examples of how to use the function. Right? So we're not asking you to write these doc strings because we're trying to keep you busy. They are actually fairly useful, because suppose now I ask for help with G. I didn't write anything. I didn't even write that it's returning something. Right? So you'd have to sit here and guess. Right? So you really do want to write a doc string. Right? Maybe you don't have to do one for like, well, you really only have to write doc strings for functions that you expect to be used by people. Right? If you have some auxiliary function in your code that says takes the square root or something, then maybe you don't need it. Okay, so there's the answer to this question. I'm putting them on the slide so you can have access to them later, but I'm going to continue coding in the IDE. Okay, so just to briefly summarize what I just said, you can call Python with this -i to enter the interactive mode. You can use dir to return a list of the names currently in the scope of Python. You can type help for any function, really, even functions that are provided by Python. I just haven't told you any of them yet. But if you want to know anything about a function, just try typing help. Right, so when you ask for help on functions, it's going to return the doc string. So please include a doc string for that reason. A student is eligible for PEY. I don't know what that is. Do you guys know what that is? Huh? A student is eligible for a professional experience year if their CGPA is at least 2. They are in year 2 or 3 and they are in a CS program. Oh, I didn't actually write a question here. Okay, so I'll append to this. Write a function which determines if a student is eligible for PEY, right, given this information. So what do we need? We need, okay, so I'm going to delete this. So what is this function going to return? True or false? So what's that category called? A Boolean. So generally I find it's a good idea to name functions which return Booleans using is, right? Whenever I see a function that starts with is, I assume that it's going to return a Boolean. I'm going to write is eligible. Is that spelled correctly? Does eligible have two L's? Is that spelled correctly? Perfect. Is eligible, okay? So is eligible needs to take three things. What is it? CGPA, year, and is in CS. Okay, so what are we taking here? So I imagine a CGPA is a real number between 0 and 4. The year should be an integer, and is in CS should be a Boolean. And we're returning a Boolean. Okay. Let's give a couple examples. So suppose I call this eligible. Your CGPA is 1.3, your year is 3, and you are in CS. What should this return? The requirement was that the CGPA needs to be at least 2. False. Okay. So is eligible someone who has a 4.0 GPA, is in year 2, and is in CS. That should be true. Okay, so how can we implement this now? So basically, we just need to check three things, right? We need to check that the CGPA is greater than, is at least 2, so that's greater than or equal to 2. And we need that they are in year is 2 or year is 3 and is in CS. Does that make sense? Okay, so let's try bringing this into Python. So Python 3, interactive mode, read in temp. I should see that I have access to is eligible. I can ask for help on is eligible. It will tell me that. Oh, sorry, to get out of here, you either hit Q for quit. Right, so you're in help, Q's to get out. So let's give this a test. Let's say is eligible, and let's just do the ones that we were claiming are examples. So 1.3, 3.0, and true. Actually, it shouldn't be 3.0. You can't be in year 3.5. So this should return false if we did it correctly. Perfect. What about is eligible? Our second example was a 4.0 average, 2, and true. True. Any questions on that? How are we doing for time? Oh, okay. I'm sorry this is a little bit boring, but maybe seeing me write a dozen functions will be helpful. So there's the answer for you in there. Write a function that returns the volume of a sphere given the sphere's radius. So what are we going to need for this problem? Okay. Well, does anyone remember the equation for the volume of a sphere? 4/3 pi r cubed. So I'm just going to write that here, right? Volume of a sphere is equal to 4/3 times pi times radius cubed. Okay, so I think we're going to need a constant, 3.14159. Should be enough. I'm going to define a function called volume of sphere, or maybe sphere volume. Make it a little bit shorter. we're going to need to take the radius, which is a real. And we want to take a real number, and we want to return another real number. We're going to calculate the volume of a sphere given its radius. We're going to need a couple examples here. So if the sphere's volume is 0, that should return 0. That's an easy one. If the sphere volume is 1, it should return, yeah, fine. Let's go into here. Pi is 3.14159. So what is 4/3 times pi times 1? Should be this. Okay, try not to cheat when you're writing these examples. Yes? Oh. Sorry, yeah. I write, there's like a half a dozen programs which I write in, all with different syntax, like conflated with the fact that like I'm actually a mathematician. So anyways, a real number is a float, but it should be float, so thank you. Back to what I was saying, when you're doing these examples, try not to like use your function. Because like these things are, we're putting these here for two reasons, right? To demonstrate to a user how to use the function, and for us to use for testing afterwards, right? So if I used my function to fill in these values, I might not actually be checking my function. So I can return here 4/3 times pi times our radius cubed. Let's read this into the Python. Let's see that it's there, sphere volume. And let's just try out our, oops, that's not right. Sphere volume 0 is 0, sphere volume 1. Perfect. Okay, let's try another one. As soon as I'm permitted, loops and if statements. Oh, we're going to do so complicated stuff. You'll be begging to come back here. Did you guys want to try one, or do you want me to keep going? You want to try by yourself, or is this going okay? Okay, I'll keep doing this. So very similar to the first question with a twist. So you're going to get the number of adults, number of teens, number of children. And the adults eat 2 slices of pizza, teens eat 3 slices of pizza, and children eat 1 slice. If a pizza has 8 slices of pizza, I want a function which takes the number of adults, teens, and children and returns the required number of pizzas. Okay, so first let's get the number of slices that they all want. So we need adults, teens, and children. Okay, so I'm going to say number of pizzas. We need children, adults, children, teens, and adults. This is a function that takes an integer, and an integer, and returns an integer. This will return the required number of pizza. Returns the required number of pizzas. I need a couple examples here. Number of pizzas. Let's just say 1, 2, 3. And let's do number of pizzas. Maybe for 4, 0, 1. Okay, and I don't know what those are yet, so let's fill in the thing. So, how many slices of pizza are we gonna have? Adults take 2, teens take 3, children take 1. So children, 1 times children, plus 2 times teens. Oh no, 3? 3. 3 times, because teens eat more. Plus 2 times adults. Okay, so that should return the number of slices, right? So, so I was going to say, recall there are 8 slices per pizza. Okay, so here's something actually somewhat interesting. We don't have if statements at the moment. All we have is arithmetic. Yeah. Yeah, but how? So that's we have quotients and remainders, right? Okay, so we do slices, integer divide by 8. So how many times does 8 go into slices? Okay, but so let me remind everyone what the double one does, right? So if you have 16 divided by 8, that means 8 goes into 16 twice. 8 also goes into 18 twice because there's a remainder of 2. That's a crap example I picked. Okay, maybe I'll try 19, right? 2 goes into 19. I'm losing my mind. 8 goes into 19 twice, right? And then 19, remainder 8 is 3, right? So you have 2 times 8, which is 16 plus 3, right? So if we have 16 slices of pizza, if I require 16 slices of pizza, and I divide by 8, that gives me 2, right? But sort of, what do we have to remember? If I need 19 slices of pizza, how many pizzas is that going to be? 3 pieces of pizza, right? So clearly this is insufficient, right? What I would really like to do is round up, right? It would be really easy to like just do the float division and round up. We don't have rounding. So what can we do? In the hood, yep. Division plus 1. I don't think that's always going to work, because what happens if I'm at 15? Or do you mean divide first and then add 1? Well, what about 16 pizzas, right? 16 divided by 8 is 2 plus 1, 3. Yeah. That's closer. Getting closer. So what do we care about? All we care about is when we divide 8 by slices, is there any remainder? If there's any remainder, we're going to need another pizza, right? Ah. That's a great idea, right? So if slices modulo 8 is not equal to 0, right? If there is remainder, what is this going to evaluate to if there's a remainder? 1. And if there's no remainder, it will evaluate to 0. Remember, 0 is false, true is... I see some confusion. How can I help? Okay, so let's go back to this example, right? So suppose I needed 19 slices of pizza, and I divide that by 8. Okay, I find that I need at least 2 slices of pizza, but that only covers 16 pieces, right? So since 19 modulo 8 is not equal to nothing, I can say I need 19 over 8 plus 19 mod 8 not equal to 0. Oh, that's supposed to cast to an int. All right. Maybe I need to do this. Yeah, okay. Right. And so if this was 18, or sorry, 16, it would be 2, right? Because this would evaluate to 2, and this would evaluate to false, which is 0, right? So I thought that was kind of clever, right? So, okay, so I'll put that here like this. So we'll just use the examples that we just used. So how can I get 19? That's 3 times 5, that's 18. 3 times 5 is 15, 17, 19. So 19, we should require 3 pizzas. 4, let's do, I need to make it divisible by 8. 4, nothing, and 8. That should be 4 and 16. No. 6? That should be 4 and, yeah. And that should be exactly 2. Okay. So let's try reading this in. So Python, enter interactive mode with the definitions in temp. Let's check that it's there. It's there. And let's give it a try. Okay, so Number of pizzas for 4, 5, and 1, we're saying is 3. Oh, I need to not do that. Great. Number of pizzas for 4, 0, and 6 is 2. All right. How many more do I got here? I'm just going to do them until we're out of time, and then you can do the remainder at home. Write a function that takes the lengths of a triangle and determines if that triangle is a right triangle. So let's give that one a try. All right. Is right triangle, right? Because I want to return a Boolean. It's going to take 3 sides, so that's a float, float, and a float. Oops. Jeez, I really am losing my mind. Let's say x, y, and z, right? So we're going to take a float, and a float. We're going to return a float. And returns true only when there is a triangle with sides, when there is a right triangle with sides x, y, z. Okay. Can anyone give me a perfect triangle? I forget my trig. Is it 3, 4, 5? Because 16... Okay, yeah, perfect. So this should be true. And is right triangle, I don't know, 0, 30, 40, 34, and 3. It's certainly not a right triangle. Okay. How can we do this? Yeah. Well, I never told you which one was the hypotenuse. So be careful. So this is why I'm trying to trick you guys, right? Read questions carefully. Don't add stuff that's not there, right? Because you would have got maybe a third of the test cases wrong for missing that detail. So finish. I'm sure you could finish, right? We just need to do what you are recommending 3 times, right? We have to give every side an opportunity to be the hypotenuse, right? So so our first try is this. So let's let x be the hypotenuse, which means that x squared minus y squared minus z squared should be 0, right? Our second trial, we're going to let y be the hypotenuse. So that should be y squared minus z squared minus x squared should be 0. Whoops. Right, so don't get confused, right? This is going to evaluate to a Boolean. So this double equals will happen before this assignment. Or C, I'm going to give z the chance to be the hypotenuse. X squared minus y squared equals 0. And what should I return? Yeah. A or B or C. Yeah, not and. Yeah. That's another option, but I don't have if statements at the moment. Right? I'm trying to design these functions with the constraints that we're currently operating on. So yeah, I could do these in. Again, there's no real one way of designing a function, right? So there's always going to be can I do it this way? And my answer to you is yeah, if it works, it works. It may work slower, maybe less elegant, but if it works, it works. So I'll repeat what this gentleman said. He said we could always look for the biggest number and assume that that's the hypotenuse, but we currently don't have a way of finding that biggest number without an if statement. So, okay, so let's read this in. Believe me, guys, I'm as enthralled as you are. Is right triangle. So is a right triangle, is a 3, 4, 5 triangle right? Sure is. Is this a right triangle? Sure isn't. Maybe I really should try the one that I put here. 0, 34, 3. 0, 34, 3. False. Okay. How many more do I got here? Write a function that returns the sum of the first n positive numbers and do not use loops. Okay. Definition. Sum of first n. Takes n. So it takes an integer and returns an integer. The description is returns the sum of the first n integers. And sum of first n for 0 should be 0. And the sum of first n for 10 should be 55. Right? Do you guys know the trick to this? I made this a question so I could tell you something interesting. But who knows the trick? And who knows the story? Okay, do you know the trick? Yeah, so there's an equation for calculating this. It is n times n plus 1 over 2. Do you know why? It's very easy to demonstrate why. I think this was Euler who discovered this equation as like a kid. Right, so, huh? Gauss. I always confuse Gauss and Euler. Okay, so Gauss discovered this when he was a child. And he was a real irritating student, not unlike many of you. And he would not stop talking in class. So in order to punish him, the teacher said, look, Gauss, you're being irritating. Go into the corner and calculate the sum of the first 1,000 numbers. And she thought that this would keep him busy. He came back seconds later with the correct answer, right? Because he discovered this formula as a kid. Who knows? I think this is mostly an anecdote, but it's still a fun story. So imagine in your head the first 10 numbers. 1 plus 2 plus 3 plus 4 plus 5, all the way to 10. What is the sum of the last number and the first number? 10 and 1. What is the 10 plus 1? 11. What is 9 plus 2? What is 8 plus 3? 8 plus 3. 11, yeah. 7 and 4. 11. 6 and 5. 11. How many pairings do we have in the first 10 numbers? 5. Or half, right? So that's the equation. To sum the first n numbers, it's just the last number plus 1, right? Times n half many pairings. That's pretty cool, right? That's a neat equation and a neat way of remembering it. So this one's super easy. N times n plus 1 over 2. We'll go through all this rigmarole again. I will check that it's there. I will take the sum of the first n numbers on 0. That should be 0. Oh, I didn't cast it properly. You see how it's turning... Okay, so I did something bad. You see how it's returning 0.0 and 55.0? I didn't follow my own design specification. I claimed I was going to return an integer. Why do we have decimals appearing? Yeah, I divided by 2. I should use integer division by 2. Right? That should fix everything. What should the... I don't know if I think you guys try. But it would just be 10 times more. Okay, so that fixes that. So yeah, remember, you should be returning the type that you're claiming to return. Right, so I made a little mistake. So remember that there's a difference between this integer division and division. How much time do we got left? How many questions do I have left? Student's volume. Write a function that takes 2 unary. Okay, maybe we'll just do this one, and you can do the other two by yourself, because this one's interesting. Okay, so write a function. Okay, so this one does require the if statement. I can't think of any other way of doing it, but take this as a preview as for what we're going to do next. I want to write a function, so I'm gonna this is gonna be very complicated, so if you don't understand this, don't worry too much, right? I want you to write a function which takes as input 2 unary functions and returns the function which is larger for a specified input x. Right? So for example, if you had 2x and x cubed, right, and I evaluated that at 3, you would get 4 and 8, and therefore you should return x cubed. Right? I wanted to point out that functions can be input to functions, and functions can be output of functions. So I'm just going to quickly do that. Def return larger unary, maybe. I'm going to take f. I'm going to take g. So now what am I taking? Well, I'm taking a function and a function, and I'm returning a function. Right? That's a type. Returns given x, which I haven't given, returns f when f of x is greater than g of x, else g of x. Right? So what are the examples I gave? So I'm going to have to be a little bit more explicit here. I can say define f as a function which takes x and returns maybe x 2 times x. Here we have a definition of g of x. Maybe this returns 2 to the power of, x to the power of 3. So when I call this return larger unary, I give it f, I give it g, I give it x, 3 maybe. This should return g, right? The function g. Because 3 cubed is 27, and 2 times 6 is 6. So how can I do this? So I'm going to show you the inline if statement, right? And it looks a lot like this. Right? So that's why I wrote it like this. I just wanted to show you how Python and English sort of look very the same. So I want to return f if f of x is greater than g of x, else g. Yeah. Well, it's up to us to say it has to be strictly greater than or equal to. So I'm choosing just to do the strict one, right? So, but that's a good example of an edge case, actually. I was trying to find examples of edge cases the other day, but that would be one, right, where the two things are equal. Okay, so let me quit this. Let us go into Python. I'm going to have to define 2 functions, so I'm going to use the lambda just because it's faster. G is equal to lambda, x cubed. Return larger unary f g. Let's give it 3. And it damn it. Okay, I can't do that. Whoops. No! Let me out. Okay. Now I can say return the larger of these 2, and it says it's the function g. Okay? I can say, so we're calling what, let's see, I can make this a third, and I think 2/3 should be large. Yeah, 2/3 is definitely larger than 1/27th, so this should be f. Great. Funny enough, you could actually just go ahead and evaluate this, right? Because it's returning a function. You can call it, but it's a little bit advanced, a little bit of I don't know, fancy programming. So the 2 I left for you is this one. Write a function that determines if a student's volume function is correct by verifying 3 examples. Right? So I basically want you to take a function and, knowing what that function is supposed to do, just execute 3 examples on it. Right? This is so you can get a feel for how we're going to grade your homework. The next one, write a function that prints twinkle twinkle little star. Right? There you go. You can print twinkle twinkle little star. And the point I was going to make here was that you can use -n for a new line, and this should still return nothing, right? We may ask you to write a function that prints something, but explicitly we'll tell you to print it. Okay, you guys have a good day. I'll see you Friday? Friday. I think so. Friday, yeah.